Got
Second,
it.
Vanessa, you're here. I want you to unmute yourself.
Yep.
Hello.
I have to get rid of this first.
Can you hear me?
I can hear you, Vanessa. Can you hear me?
Yes. Hi, Sean.
Hey, terrific. Why don't you start sharing your screen and I will give you your introduction. So,
Right.
Vanessa Warheit is from projectgreenhome.org. She's an advocate, an organizer, a strategist, and a storyteller. Vanessa is a leader in the fight for social and environmental justice. She has used her expertise in communications to advocate for a range of equitable climate solutions, including redirecting finance flows away from fossil fuels, supporting renewable energy and efficiency, redesigning our urban environment, and electrifying everything, including transportation. Vanessa was most recently the executive director of Fossil Free California, a 501c3 dedicated to moving money out of the fossil fuels and promoting a just transition to a clean energy economy that works for everyone. She has also led communications and campaigns for 350.org, the Bioneers, the League of Conservation Voters. As a documentary filmmaker, she produced The Insular Empire, a PBS feature documentary about America's colonial territories in the Pacific, and the award-winning kids video, Worse Than Poop, which may still be the only funny film about the climate crisis. Gee, I'd have to watch that. She is a certified leader with Al Gore's Climate Reality Project, an advisor to 350 Bay Area, and a member of the Emerge California class of 2021. Vanessa is currently engaged in a zero carbon retrofit of her family's house in El Cerrito, California, a process which she is documenting at bit.ly/Casa Warwingle. Yay, Vanessa!
Thank you. And I apologize for the printing sounds in the background. I've been fighting with my printer and only just got it to work. But I think
Gotcha. You're forgiven.
Almost done. I just realized I can't see my notes if I'm sharing the screen over Zoom.
Okay.
Okay, there. It's done. And I'm all good.
Great. I'll mute myself. Take it away.
Okay, thank you so much. It's really an honor to be here with this amazing lineup of speakers. I'm going to be speaking to you all today about excuse the printer noise, about an effort underway right now to get the CALGreen building code more ambitious with regards to EV charging access for all in residential and non-residential applications throughout California. I'm going to walk you through what the current mandates are here in California, walk you through some EV terms, then take a nitty-gritty look at the codes and what we're proposing, provide you with some brief kind of cost analysis that we've done, and then leave you with a few of the rationales for why we're doing it, and then sort of give a sense of where we are now and where we hope to go. And I'm sorry, I'm going to ask a quick question, Sean. Like, I've only had been able to sort of briefly dive in. I have a feeling this is maybe a mixed crowd with like some deep technical knowledge and then maybe some less so. Is that accurate?
Yeah, well, there's like 107 people, so it's a pretty wide mix.
Got it. Okay.
But when I was zooming through the list, it was everyone from architects to engineers to developers to policymakers to utility workers to energy modelers to activists. It's
okay.
Okay.
So those of you who are like, have electrical engineering degrees, please bear with me. Some of this is really obvious. For those of you who are policymakers who don't maybe have an engineering or a technical background, also please bear with me, and I'm going to try to cover the gamut. All right, so where are we? Here in California, we have 3 electric vehicle mandates currently from our government. Senator De Leon, back in 2014, got SB 1275 to pass, saying that we need 1 million zero-emission vehicles or near zero-emission vehicles, read plug-in vehicles, by 2023. We are not there yet, but we are potentially on track to get there, especially now with the Biden White House. In 2018, Governor Brown passed an executive order mandating 5 million zero-emission vehicles on the road by 2030. That's obviously very ambitious in 7 years to 500% what we've been able to get over the last 10 years, but I actually think that is possible. And then Governor Newsom just last year passed an executive order mandating that there will basically be no more gas light duty passenger cars or trucks sold in California new as of 2035. So that's all totally doable. It sounds crazy ambitious. It's obviously where we need to get. But the question is, if you're going to create all of these wonderful EVs and have them on the road, where the heck are they going to charge? So the good news. If you don't already drive an electric vehicle, then you may not know that they are way cheaper, both to fuel, but also especially to maintain. They have a small fraction of the moving parts of a gas car, and they last a whole lot longer. And when they fail sort of long and gradual. Batteries have a sort of long tail life versus a sort of catastrophic failure you might have with a gas engine. They're also way more convenient, assuming you can charge at home or even at work. You just put it, you park it and you plug it in, and in the morning, whew, it's done, versus having to go to a smelly gas station. They are safer. Look at the ratings. They are way more fun. Those of you who have ever test driven, and if you test driven a Prius, that doesn't count. You have to drive an all electric one that has a motor that puts all the torque straight to the wheels. They're super fun. They are way healthier. They have no local criteria pollutants, no tailpipe emissions. You don't have to go to the stinky gas station. And they are powered by electricity. And as we all know, the grid is getting cleaner and cleaner. So they're just better for the planet overall. But who gets most of these benefits? In California, it's mostly single family homeowners right now, especially if you live in a new single family home. So the state building code, which we're going to talk about in a minute, currently mandates, and has since 2016, so for the last 5 years now, that if you build a brand new single family house, it must be wired EV capable. However, if you build a new multi-unit dwelling or let's an apartment complex, motel, hotel, it's gone up sort of incrementally, and they are currently proposing that it be a whopping 20% of multi-unit dwellings that units in a multi-unit dwelling site that would have access to it would just be even capable, let alone EV ready. And I'm going to talk
Inadequate.
Inadequate. Thank you. Paltry and milk toast are the nice words for that. So under the current proposal that we are proposing, single family, let me just say, over the code cycle, this is a little bit ahead of the curve, but let's just bear with me. Basically, over the 3-year code cycle that we are looking at, which is 2022 to 2025, there will be approximately 150,000 new single family homes added, and there will be approximately 150,000 new units, apartments, and condos, and other multi-unit dwellings. The savings that will accrue to the drivers in those single family homes is more than double what will accrue to the drivers in the apartments and condos, because the cost of driving an electric vehicle is so much less. And that doesn't even account for the health costs or the climate impact costs. So what we're trying to do is to change the new CALGreen building code. So CALGreen, if you're not familiar, probably a lot of you on this call are familiar. It's Title 24 of the California Building Code. It gets modified every 3 years, and the 2022 input phase is happening basically right now. I'm going to show you in a moment a chart of their timeline so you'll understand where we are. The subject matter experts are the California Air Resources Board. They advise 2 different agencies, Housing and Community Development, which works on residential, and Building Standards Commission, which works on non-residential, and which also incorporates HCD's code into Title 24 CALGreen. Our opposition is largely inertia and ignorance. The Building Industry Association has typically been on the wrong side of this argument. They have actually been more helpful to us recently. So I'm not going to malign them on this call, but I am going to say that typically a big concern of theirs has been cost. And as you will see, what we are proposing actually will cost less. And I think that's part of the reason that we're hopeful that we may actually make some progress finally on this issue. So in brief, what we're doing is we are proposing to take the REACH codes, which were developed by two local community choice energy providers, Peninsula Clean Energy and Silicon Valley Clean Energy, both here in the Bay Area. They basically created REACH codes that were based on prior REACH codes, which had been developed in San Francisco, Fremont, Los Angeles, and Palo Alto, evaluated them, negotiated them, and created this new set of REACH codes, sort of model code, that has since been adopted in part or in whole by almost a dozen cities now around the Bay Area. And more are, like, we just last month got requests from Santa Barbara, could they use these? So a lot of cities that are kind of forward thinking and have the resources have been reaching out to try to implement them at a local scale. What we want to do is we want to level the playing field for all California communities to lift all electric powered boats and get everybody access to a bare minimum EV infrastructure in new construction. So here is the triennial code adoption cycle. The circle is where we are right now. And I'm going to say that this, if you've never seen this, if you're super familiar, bear with me. If you've never seen this, I'm actually coming new to the code process. I'm not new to EVs. I've been driving an EV for the last 8 years. I've done EV advocacy all sorts of ways, but this is the first time I've worked on the building code. And I was shocked, but maybe not surprised, to learn that right now in January of 2021, we are almost too late to be influencing this cycle. Even though it says, you know, all these little stars indicate that there's public input, really, if you haven't given your input by January, it's almost too late. So there's a long kind of invisible process that happens, but the time to be speaking up is right now or yesterday. Okay. With apologies to all of you out there with engineering and physics degrees, this is for those of you who do not have that background, and very basic terms that we're going to be using. So volts is, you can think is in electricity, is kind of like water pressure, how much is coming out of the same tube. Amperage is like water flow, how big is that tube, how much of it is there. If you multiply those two together, you get power measured in watts, or in the case of electric vehicles, which take a lot of power to haul all that metal around, kilowatts, 1,000 watts. And then energy is that power measured over time. So you might, and that is often how we measure the cost of power. The cost of driving an electric car is in, for instance, 30 cents per kilowatt hour. So those of you who are not familiar with driving an EV, this is how charging works. There are 3 different flavors of charge. Actually, I'm going to say there's 3 different speeds, and then within each one, there are different flavors. So 50% of EV drivers charge at level 1. Every single EV comes with one of these adapters that you see on the left. On the one end is what's called a J1772. It's also the same as the adapter you see at the level 2 there. But on the other end, it's just a plain old plug. 110 or 120 outlet that you would plug in your toaster or your coffee maker. You can charge an electric vehicle on a regular old 120 plug. That'll give you, we call it trickle charging, and that'll give you 3 to 4 miles per hour of charging. Level 2 is if you've seen it, maybe your local library or your local Whole Foods might have well, Whole Foods now sometimes has DC fast charging as well, but a lot of parking garages now have these level 2 chargers. It's basically the same amount of power. It's 240. It's what you'd get out of a dryer outlet. And that comes in different flavors. So you might have like this Bosch one, that's something you might have at home that you'd have an electrician wire into your garage. But you could also get an adapter, like you have the level 1 adapter. You could also have a level 2 adapter that would go from a J1772 that fits on your car straight in to the dryer outlet you might have in your garage. And then the other really fancy flavor with cherries and nuts on top is like a commercial charger that's got so much electronic whiz-bang stuff in it, it can like fry your eggs and take your kids to school. Like it's super fancy, it's super expensive. They're networked, they might do load sharing, they might do charging, they'll connect you to a national network. It's like ChargePoint or EVgo. These bigger companies have charging stations, but they're delivering level 2 power, which is typically 7.2 kilowatts, somewhere between 6 and 80 amps, 240 volts. That level of power, that flavor of level 2 will get you between 25 and 30 miles per hour of charging. So if you go to Whole Foods, you plug in at a level 2, you charge for an hour, you come out, you now have 25 miles more that you can go on your car. The last super fancy, fabulous for long distance travel flavor of charging is DC fast charging. You cannot get this at home. It is so much power, it'll kill you. Like it's super, super fast. You can charge somewhere between 72 and 1200 miles per hour. It really, really varies. Different companies, different machines offer different, there really is, that's where there's the biggest range of difference in terms of power supply. Okay, so when it comes to infrastructure, there's a few things that we are asking the state to do. One of them is to redefine the definition of what it means to be EV ready. To us, EV ready is when you can actually plug it in at the place where you have parked. And it can be either level 1 or level 2. It can be a receptacle, right? Like an outlet, or it could be one of those fancy charging stations. And most of all, it must have signage. There must be big green letters that say electric vehicle outlet here. That serves a number of purposes. One important purpose is education, because if you don't drive an EV and you see a little old regular plug and a big sign that says electric vehicle charging, you're going to suddenly realize two things. One is, oh, if I got an EV, I could charge here. And two, I didn't know I could charge an EV off of a 110 plug, but you can. So it serves a huge purpose. Now, what CALGreen is currently proposing is no signage at all, panel capacity. So you're paying to upgrade the panel to provide enough power for these spaces, but, and raceway and like conduit going to all these places, and the wires, the copper to get there, and maybe a plug outlet, or maybe just a junction box, just a blank stainless steel plate, which has gotten this guy biting his steering wheel, because that's super frustrating, right? Like, what's the point of that? That's not EV ready, that's just EV crazy making. The next definition we want to change is EV capable. Their definition is less flexible, more expensive, and invisible. So similarly, we want signage, 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 not just at the panel, which is what they're saying, oh, we have to have the panel capacity. You have to have conduit and raceway, which is very expensive. You have to have a minimum of 7.2 kilowatts per space, but the signage is only going to be at the panel. So someone driving up isn't going to know that they just spent a ton of money wiring it all the way to the parking space, but not providing it. What we're saying is, make sure that the panel, yes, has enough power, but don't give it 7.2 kilowatts per space, give it 1.4. A bare minimum should be every space with the ability to have at least level 1 trickle charging. We're also saying, to be capable, you don't need to run wire to every single space if you're not yet using it, but what you do need to do is put in conduit and raceway at what are called pinch points, any place that would be hideously expensive or complicated or difficult to get to later on. Think trenching or concrete, digging out concrete, right? Places like that, pinch points must have raceway laid, but not wiring, just raceway, so that someone can come along later and finish the job. But finishing the job at that point is fairly trivial. And signage, 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 not just at the panel, but also at the spaces, again, for public education and to help bring potential drivers and current EV drivers to help them advocate, which is what it's going to take to get from EV capable to EV ready. Let me say a quick word about load management. So we are now living in a wonderful age, and this actually has just happened in the last year or two, where we're now able through software to manage load across multiple ports. In what CALGreen is currently proposing, which does not include load management, if you have 4 parking spaces and you have 7.2 kilowatts of power, only one of them gets power. All the other 3 have to sit and wait. So if I get home at 5 o'clock and no one's there yet, and I plug in, after an hour and a half, if I'm a really nice neighbor, I'm going to call Sean, my neighbor, and say, Sean, I'm done. I'm going to go downstairs and move my car and let him know that he now needs to come home at 6:30 and move his car. And we play car like shuffling games, which most people just don't even do. It's basically just one person's hogging all the power. Their car is done charging and everyone else is just SOL. With load management, instead, I come home, I plug in for an hour, hour and a half. I mostly charge. Sean comes home, he plugs in, and now we're splitting the load between us. When I'm done, all that load goes over to Sean's car. Meanwhile, 2 other people come in and plug in. Now that load is shared between them, and it flows like that. So at the end of the day, everyone has had a bare minimum of 1.4, but most likely they've gotten closer to what they need if they do need more. But 50% of EV drivers right now charge at level 1. I've got a Tesla Model 3 sitting in my driveway charging on a level 1 cord that's literally just pulled out of the garage in our rental. Okay, here's the nuts and bolts of the code that we're trying to change. What CALGreen, and there are 2 slides that look like this. This one is for multifamily. And remember, there are 2 pieces. There's the multifamily residential code and the non-residential code. For the multifamily residential code, what CALGreen is currently saying is acceptable is 20% of multifamily units get EV capable, according to their crappy capable definition. And what that translates into, interestingly, if you were to amortize that 7.2 kilowatt EV capable, which doesn't really help anybody, across all of the available spaces, lo and behold, it comes out to 1.4 kilowatts per space. So what they're proposing is 20% have to have full power level 2, 80% will probably never be able to charge, and it's only EV capable. So the residents have to now go to their property manager or their own building owner and advocate and clamor and beg and plead to get them to go that last mile and convert it to EV ready. And only 20% of the spaces will ever be able to charge. And the one concession they've made is if you have more than 5 units, there has to be 1 level 2. That 20% must be satisfied for if only it's 5 units, or anything over than that additional 1 level 2 EVSE, which is basically a charge station, like not where you bring your own charger, or it's not an outlet, but you actually have a charger station there. Totally not enough for where we need to go. So what we're saying is no, if you have up to 20 dwelling units, 100% of them have to have outlets, EV ready, wired, live outlets per unit. And there's another critical difference between what we're recommending and what they're recommending. This is super interesting, especially if you're interested in public transportation and decarbonizing that way. Their current definition is 1.8 parking spaces per building unit. And so all their calculations are based on that. What we say is this is only applicable to units with parking. So many building units are built now, if they're built close to transit, maybe they don't include any parking at all. And we say, great, fine. That's wonderful. The world needs less parking. But if you're going to build more parking, it must be EV ready. And then if you're building, you know, a ginormous parking lot, 25% of those spots need to be EV ready, and 75% need to be level 2, and 75% need to be level 1. But still, everybody, everywhere, this is what we call charging access for all. Everybody in that brand new multi-unit dwelling has access to an outlet of one kind or another. And as before, EV signage everywhere at all outlets at the spaces, not just back in some electrical panel somewhere. With load management, we can do this level 2, but with a minimum at 1.4 kilowatts per space. And now I'm going to switch over to the non-residential side. What they're proposing is 10% EV capable. And remember, these are brand new office buildings, brand new. And they're saying it's acceptable to have, for anything over 10 spaces, to have only 10% of them be wired as EV capable. And if you have fewer than 10 spaces, goose egg, nothing required. So any small commercial development is completely off the hook and can just build basically obsolete parking spaces. The one additional requirement, minimum requirement, is 1 level 2 charging station per site, again, over 10 spaces. That could be 1,000 parking spaces, could be 100 parking spaces. I call it the 1%er charger, because one lucky soul gets access, but everyone else has to drive a gas car, I guess. I don't know, but it's definitely not, it's not enough. So what the Peninsula Clean Energy Reach codes say is first of all, they bifurcate based on use. If an office building, and an office building also might be like warehouses, if the vast majority of the people parking there are parking there all day long, then we want 50% of those spaces to be either EV ready or EV capable, with a minimum of 20% being EV ready, 10% charge stations to really promote it and get lots of people know what's going on, and also level 2 capability, 10% level 1, but again, ready, so you can plug in your own adapter, and 30% up to you. Different communities have different adoption levels. You choose what makes more sense for your particular use, and signage everywhere. Commercial or retail parking is different. So originally the PCE proposal was 5%. We've upped it to 10% because that's about the percentage of the people who work there. People who work there are going to need to charge. They're going to be there for 9-10 hours maybe for their shift. They should be able to charge at level 1 and get, 30-40 miles of charge while they're at work. The other option is, instead of those level 1 EV readies, if you have a really big lot with more than 100 spaces, you could instead put in 1 DC fast charger for every 100 spaces. And again, signage, signage, signage. So just a reminder, this is what our mandates are. We have to have 5 million on the road. We currently have about 750,000 on the road. So where are we going to be able to charge? The other question is, how much will this cost? And I mentioned the building industry is often concerned about cost. Well, as it turns out, retrofitting is way more expensive. The orange bars that you see here are based on a cost analysis that was done for Peninsula Clean Energy and Silicon Valley Clean Energy. They found that it was approximately 3 times the cost of doing it in new construction. However, when you're not the one really paying the bill and you can foist it off on your ratepayers, it can go substantially higher. So that's kind of a minimum. PG&E's cost per port for its EV charge program was $18,000 for its retrofits. So somewhere between 3x and 14x is going to be the cost difference. Here's a couple of comparisons. So now we're in residential land again.
I just want to draw your attention. You got about a minute left. Just so you
got
know.
it. Okay, so I'm just going to let you just take a look at this. The upshot is it's way cheaper to do what we're saying. We serve way more units. The cost per space is substantially cheaper. the hassle factor is cheaper, the greenhouse gas emissions are lower, and the amount saved by the communities who enjoy them is substantially higher. And the same goes for non-residential as well. And I'm happy to dig in more. I'm happy to share these slides. I know I've probably gone way above time. I don't think I have time to really dig into this one. This one just gives you more data on why this is cheaper and how much money it saves for the vehicle owners and how much CO2 is avoided. And I'm just going to leave you with this last rationale. Equity is super critical. What they're proposing is inequitable, and we need to make sure that low-income communities, communities of color, frontline communities that have borne the brunt of fossil fuel infrastructure and fossil fuel driving have access to electrified driving. It's way cheaper to do this up front. Building turnover is only 1.5% per year. We have to, right now is already too late. We have to be putting this in right now. And the benefits are enormous, and daytime charging in particular is really good for the grid and helps avoid the need for we already know we're going to need storage, but it really helps address the duck curve from solar. This is the coalition that we have put together. The legislature, Senator Becker and a consortium of legislators from both houses have already written to them about this, but they still need to hear from more people. If you'd like to join us, we have a Slack team. These are our emails. And I guess I'm out of time, but thank you so much.
Hey, Vanessa, leading the charge on equity for all. I like my analogy is it's wrong that people who have less money would get literally stuck in the slow lane for lack of having an electric car charger. It's like, I mean, it's just so unfair. How many layers of unfairness do we need to put on people, including not giving them access to the fast lane?
Right.
So they get to work on time, you know?
Yeah, right.
This is terrific. There are some comments, questions over on the chat side, and I hope that everyone does join, help, push hard to get electric vehicles. As we're seeing in these discussions today, there's opportunities to use them as grid resiliency and building resiliency resources. This is huge for all of society that we get electric vehicles and the big batteries that they have and get them available. Okay,